Okay, I'm back because Lee's a tool. Okay. All right, so this is a brand new project. So some of the stuff we're gonna be doing we kind of covered last week, but we're gonna be doing a lot of new stuff too. So I want to use the teleporter to go over UFUNCTION and UPROPERTY specifiers and kind of give an idea of when to use them, because there's a lot of different ways you can access your C++ code, either from other code or from blueprints. So that's what we're going to do tonight. I wanted to have some of the preliminary work done ahead of time, but life got in the way. So we're going to create a new actor, and we're going to call this, we'll just call it teleporter. No, we'll be more descriptive. We're going to call this teleporter base, because what we're going to do is we're actually going to use this and we're going to derive several children classes from it, but we're going to do some work inside the teleporter base that's going to make it easier later to differentiate our teleporters from one another, but it's also going to be the first thing that we're going to talk about visible versus edit anywhere, and we're also going to talk about the different types of edits we can do on properties. So if you were here last week, we were building our components, and I made it edit anywhere, and my interpretation of what edit anywhere does is incorrect, or was incorrect. What edit anywhere does is it basically lets you edit where that component is pointing, because we're creating pointers to components, right? And so edit anywhere basically lets you change that reference, and it's not really ideal for components. That's more for properties and that sort of thing. What we should have been doing is hey lady, how's it going? Hope you're having a good Friday. But yeah, what we should have been doing is using visible anywhere for our components, and then edit anywhere, the other edit things for our properties. So we're going to move over to code, and so a lot of the stuff that we're going to start with is stuff we already did last week. So we're going to kind of blow through this pretty quickly. So we're going to include components, scene component, include our header file for that, and we're going to include components, static mesh component, and finally we're going to include our box component, because that's what we're going to use to build our teleporter. And we're going to make a protected section up here, and we're going to put all of our components that we already talked about last week in here. And the only thing we're going to change is we're going to change the U property to visible anywhere. Because the thing is, and if I had thought about it a little bit, just because it's visible anywhere, if any properties that component has are still going to behave the same way. So if it's a property that's editable, then we can still edit it in the Unreal Engine editor, even if it is set to visible anywhere. So all this property does is determine the way we can access the reference to the actual component. So we're going to do a scene component, and we're going to call it the scene. This is going to be our root component. And we're going to do another UProperty. Visible anywhere. I'm going to be using this a lot, so I'm going to copy it real quick. Maybe. That's, oh. And then we're going to have a static mesh component. And this is going to be our entry point. Then we're going to have a box component. And this is going to be our entry trigger. And finally, we're going to have another static mesh component. And this is going to be our exit point. And let's just say, let's see, these are our, we're just going to call this like the, we'll just call it teleporter components. And this is our entry platform. This is going to be our teleporter volume. Nope. I got this wrong. This is going to be our teleporter volume. This is our entry platform. This is our root component. And then lastly, exit platform. Now, now we're gonna get into some crazy stuff. Actually, before we move on, the other thing is we want our exit point. This is gonna be it's more a matter of preference. I don't really like having the. There have been times where I'll have something. I'll have a static mesh component that's the root, and then like, you know, maybe I want to move pieces of it around, but I don't want to. I don't want to like change like the epicenter of that thing. It's just a matter of preference because I want each component to have a singular purpose, and so I just prefer to have a scene component that just behaves as my root, and then each component under it just does that thing. So there's nothing wrong with doing it that way. I just know that I've struggled in the past where I've had the static mesh as the root, and things don't behave the way I want them to. So it's just something I've gotten the habit of doing. You don't have to do it that way. There's nothing stopping you from doing it a different way. It's just how I prefer to do it. This blueprint read-only specifier means that we can access the exit point component in blueprints. I mean, theoretically, we could do that for all of these, but we're not really doing anything right now. That's the only one that we're actually interacting with in any way, other than the only two we're doing is the trigger, the box component, and the exit component. And for what we're doing with the box component, we don't need blueprint read-only. Because we already have access to that event. But we are going to mark the exit point blueprint read-only so that we can access it later. And you'll see why when we get there. So now what we're going to do some crazy stuff. I want to talk about the edit properties and how we use those with our class properties. And we're going a little bit out of order, but the one that I want to go over first is UProperty edit instance only. And basically what this means is you're going to have a property for your class, and you cannot edit the default value, but when you create an instance of that class, when you create an object, then the property will be editable. And I'm doing it this way, A, to just demonstrate how it works, and B, so that we have the same consistent starting point and we can edit it from there. And then what I'm going to do is we're going to do a meta tag. Meta tag, I don't really understand. Meta basically kind of loops some, like, I guess, sub properties together. It's just metadata that enhances the property that you're working with, rather than how the editor accesses it. I can't really explain it very well, but what we're going to be doing is we're creating a linear color, but I don't want to deal with the alpha channel, so we're going to hide the alpha channel. And this is going to be an F linear color, and we're going to call this entry color, which is going to be an F linear color. And this is the default color for the cube material. So and basically what we're doing is we're going to I'm creating a way to visually change our teleporters so that we know which one we're dealing with, and at the same time demonstrating how edit instance only works. And this one's going to be our exit color. Now, to do what I want to do what I'm kind of what I want to do, there's a couple of other things that we need. This is a little bit more high level. This is something that you're going to learn for all my fellow SNHU people. This is going to be something you're going to be learning in game 415. So if this goes over your head right now, don't worry about it. This is just some preliminary work for helping us visualize it later. But we're going to do a material interface, and this is going to be our entry material. And then we're going to do the same thing for our exit material. And then a new material dynamic instance, entry instance, and exit instance. So what we're doing here is we're creating a dynamic material that's going to be applied at runtime, and this is to me an easier way of creating multiple instances of the same material without actually like creating material instances in the editor. It's just an easier way to do it, or I won't say easier, it's a different way to do it. Control D, really? What are you talking about? It's just adding a line for me. Mother of God. Bro, my whole world has changed. Oh man, that's amazing. Did I? I think I messed something up. Why are you doing that? What's wrong with you? I think IntelliSense is just being weird. Material dynamic instance is undefined. I am forgetting something. Or maybe it's just trying to catch up. I don't know. Let's try building. Let's see what happens. Because we just put a lot of code in. I thought it might be the header file, but I actually have notes this time. I've already written this code once, and so I was looking at my code that I have. And yes, y'all are my ducks. But I'm looking at the code I have, and I don't see an include for that. So we're gonna sit here for a second and see what happens. Cool story, bro. Did it work? It just failed. Just straight up failed. This was working earlier, and of course I start streaming and everything goes sideways. All right, let's. Oh. Okay. It's not U material dynamic instance. It's U material instance dynamic. That's why. That's dumb. So yeah, the generated body is, I believe it's a macro that's part of Unreal Engine, and you're just always going to get that. Well, I won't say always. Sometimes it goes away, but it's usually there. You can ignore it. Okay. So we should be good now that I have my words in the correct order. And we get to hurry up and wait. How was everybody's Friday? Oh. Oh no. Oof. That doesn't sound fun at all. I hope you guys stay safe. Damn. You guys are bumming me out. Just a little one? Is there you know what? I guess that's fair because I'm in Texas, and so like, you know, we have like, oh, it's just a little a little tornado. It's fine. Yeah. I guess that's the same thing. You guys have little hurricanes, we have little tornadoes. Okay. So we didn't break anything. And let's follow good practice here. Dynamic material instance information. Entry platform color. Exit platform color. We're going to call this base material. This is also base material. And then entry mat instance and exit mat instance. All right, so there's one more thing we need to do in our header file. Small healthy hurricane. Oh man. Okay, so there's one more thing we need to do. We're gonna have a function in our protected section. This is gonna be U function. This is gonna be blueprint callable, and we'll discuss later why it's callable. And this is gonna be void activate teleporter. And so basically what I'm doing to reduce the amount of code I have to write is we're gonna put the actual teleporting action inside this function in our base class, and then whenever we need it, we're basically gonna wrap it inside of another function that belongs to the child classes, because the way that the children classes behave with this is going to be different. But I just don't want to rewrite it or copy and paste it, so we're gonna have a protected function here that's going to actually do the work. So that's it for our header file for our base class. Now we need to take all this stuff and actually put it, write the code. Oh, I'm sorry. There's one more we need. Virtual void post-initialized components override. The post-initialized components is just a function that's going to actually initialize our dynamic instances. Basically what's going to happen is the components initialize at the when you start the game, but in between initialization and begin play is a post-initialization phase, and that's where the materials are going to be applied. So we need that. So now let's move over to our base and let's define all this stuff. And so we're going to start with our root component. And we're going to say this scene equals create default sub object using component text scene root. Boom. And then root component equals this scene. Yeah, yes, that's what we're doing right now, Node-as. Entry platform. So it's amazing. Entry point. Static mesh. Entry platform. And then we're going to do entry point, and because this is a pointer, we need to have the arrow. Set up attachment to our root component. And now let's do the same thing for our exit point. exit platform, and then one more time. Oh no. And then this is going to be our entry volume. And what did I call this? I called it entry trigger. And then this is going to be a U box component. Entry box volume. And then this one is going to get attached to our entry point so that these two guys move together. This is all stuff that we did last week. But now what we're going to do is we need to define our materials. And the way we define our materials is Unreal Engine has a class called constructor helpers. And basically it will search your content folder for specific assets and can assign them to your properties. And since we're not going to be changing this material, then we're going to use the constructor helper to assign that asset. So what we're going to do is we're going to define entry material, and we have to put it in brackets. I don't know why, that's just how they do it. And we're going to call, and actually before I do this, oh no, okay. I wasn't sure if the constructor helper is required in include or not, but it doesn't. Constructor helpers F object finder Did I spell it wrong? Constructor helpers. No? Okay. Right, we'll keep going then. Follow me. Oh, okay. It's just mad because I haven't finished. A new material. Asset. Text. And this is going to be basically the path to our material. And I'm just going to copy and paste this in here. So this is essentially the equivalent of our content folder, geometry, meshes. This is the material we're using right here. And so that is the path that we're including here. The interesting thing about using this is it's basically when you get to the actual asset, it's asset name dot asset name. I don't know why they do it that way, but that's just that's just how it goes. That's just the way they do it. And so now what we're going to do is we are going to assign this object. So this is finding the object for us, and then we are going, and it's assigning it to this asset object right here. And so we're going to do entry mat equals asset dot object. And we're also going to do the same thing for exit mat. What are you talking about, Lee? Fully armed battalion to remind you of... Did I miss some chat, or are you just having a stroke? Okay. I'm a little concerned No, I've not seen Hamilton. Sorry, buddy. I'm a little concerned with that. So we're let's just build real quick, see what happens. Yeah, so we're basically just finding an object, assigning it to this, and then we're finding another object, and we're assigning it here. But I don't know why I'm getting these. Mine's been okay. It's been kind of uneventful. Did some work, made some dinner, doing this stream, and then I'm gonna play with my daughter for a little bit before I sit down and play some Final Fantasy 14. Post-Initialized components. What? Post-Initialize components. And I know why this one, I know what's happening here, because we haven't created a definition for it. So let's do that real quick and get that out of the way. All right, Lee. I'm recording this. Oh, I'm not recording this. I'm recording it now. I thought I was recording it. Yeah, man. Just let me know. But yeah, if you wanna watch this later on my Twitch, you can. I'll try and export to YouTube. I haven't done that yet. I don't know. I haven't tried that yet, but we'll see how that goes. But I'm also recording it locally, so if you want it later, just let me know. All right, let's try and let's create the definition for this one as well, so that it doesn't yell at me anymore, because we're going to need it anyway. We're going to need it here in a second. Let's try and build again, because I don't know why. Constructor helpers. F object finder. Because I'm not seeing. I don't see an include that I'm missing. Oh, okay. We won. Cool. That was weird. I don't know why it's mad at me though. But it built just fine. So we'll keep going. All right. So we are done with our constructor. We're going to do post-initialized components, and then we're going to write our actual thing, or our actual, what this actually does. And then we're going to, no, there's no arrow before it. That's just because this right here is a template. It's a C++ template. And so whenever you define a template like this, the variable name comes right after it. So, nothing in our error list. Okay. So So the first thing we're going to be doing here is we're going to do a super post-initialized components, and basically what this is that it's calling this from the base class that it's inheriting from. That's what super means. Is it's running this. So when you have a hard, I'm going to call it a hard object. It's not really a hard object, but when you have an object like this, Lee, like my linear color, if you want to, if this is as an object that has functions that are associated with it, you use the dot accessor, like, you know, class dot function name, right? So if I've got a player character that jumps, it would be player dot jump, right? But when you have a pointer like this, so this is probably a better example. You know, if you have a uStatic met, if this wasn't a pointer and you wanted to set it up, it'd be entry point dot setup attachment root component. But since it's a pointer, you have to dereference the variable, because the variable is not pointing to an object, it's pointing to an address where an object exists. So the arrow dereferences it from the address so that you can access all of the methods inside of it. So it's the dot functionality, but for C++ pointers is what it is. Okay, so post-initialized components, and then if entry map. So this is the material we just defined. We're making sure that we have one, that there's a material that exists that met in this path, and we're going to create what I called it. Yeah, we're going to create a dynamic material, which is basically a material that is applied at runtime. New material instance dynamic create entry mapped this. And I would tell you what all that means if my IntelliSense was working. Now that we have that instance, we're going to set a vector parameter, which we don't have set up yet, but we're going to do it before we run this. It's going to be called color, and it's going to be entry color. And then we're going to set our material for our entry point in the material index 0, so it's the very first material, to our new instance. And we're going to do the same thing with our exit material. So we're defining our material, we're creating a runtime instance of that material, we're setting the color of that instance, and then we're setting the material of our object, of our static mesh, to this instance material. That's what all this mess does. And it's going to make sense why we're doing that here in a second. I promise we'll get to doing some cool stuff here in a second. And then last but not least, we have our activate teleporter. We've got this target actor that we're passing to it, which is of type actor. And so this is the same thing that we did last week. We're going to go teleport to, and I'm just going to do this all in one line. So we're going to get our exit point and get component location, and then we're going to get our exit point, and we're going to get component rotation. That's all that does. Pretty simple. And let's build. And let's see how this goes. Oh, no. I saw a typo. Now let's build. And really, we don't need the tick function. And we don't need the begin play, but I'm not worried about taking them out right now. Any questions so far while this is building? I know this has been pretty riveting up to this point, but once we start building some child actors, it's gonna snowball. I'm hoping it'll make more sense as we move on. Oh, there's another typo. I'm good at that. Is not a member of eMaterial instance dynamic. Set vector parameter. Oh. Set vector parameter value. Now we should be good. Okay, so let's move over to Unreal, and we're gonna make a blueprint class based on our teleporter, and we're gonna call this BP underscore teleporter base. Put it in our blueprints folder. And before we move on, there's one more thing we have to do. We have to come back to this material. Let's open it up. And we need to create that parameter that we're setting right here. And it's pretty easy. All we're going to do is we're going to take this color that we have right here, right click, convert to parameter, and we're going to call it color. Save. And so now this is the same thing we did last time, right? We got our entry point, and we're going to set this to a cube. Let's drop this to 0.25, and we're going to set this one to a cube, and I'm going to call this 0.25. Now, the first thing I want to point out, and this is going all the way back to this edit instance only that we did for our linear colors. Well, actually, before we go there, remember that these were all visible anywhere, but we just saw that I was able to change the static mesh even though it was visible, right? Instead of edit, because edit doesn't necessarily equate to being able to edit the object's properties. It's editing the object itself. So, and then the other thing is we have edit instance only on our entry and exit colors. And so when we come over here and we select our teleporter base, we're gonna see in here that there's nothing here that has to do with our color, right? If we come down here to the entry point, static mesh, we have this material here, but there's nothing in here that talks about being able to edit this color. However, once we put one of these into the world, and let's move this out, you'll notice now that if we come down here, oh, I gotta select the thing. And we need to go down, here we go. Here is our entry color and our exit color. And they're editable. So let's do blue for the entry. No. Let's do blue for the exit. And let's do green for the entry. But you'll notice it's not changing, right? This is, remember what I said, that the material is changed at runtime? So if I play, now you're going to see we've got materials on here. And if I pull another one of these guys out, whoa. And let's just change this one to something random, because I can put the numbers in, or I can just open up this because it's a linear color. The editor knows how to behave with this. Right, so let's just do that, and then let's make this one over here, and then we can play, and there we go. So that's how edit instance only works. Is it allows you to change the instance of objects, but not the defaults. And likewise, you have edit anywhere, which will allow you to change the defaults or the values that are in the instances, and then you have edit defaults only, which obviously allows you to change just the defaults. Now, you'll also notice, however, that if I walk on these are our entry points, it doesn't do anything. And that's because, well, we have our teleport method, we have our teleport function, but we don't have a way to call it. We don't have any sort of trigger to do that. And so that's what we're going to do now. So we're going to delete these guys. And of course, if we wanted to, now that we have this one, our teleporter base, we could just put all of this in here. We could just put all of our teleport code in here. But that's not really our focus, right? We want to do this in code. So what we need now is we need to, there are really three ways to call that code. And that's what we're going to go over. So we're going to create a C++ class derived from our teleporter base. And so this one is going to be called teleporter callable. And give that one a second to compile. So we have callable, we have blueprint implementable, and then we have blueprint native. And they all pretty much do the same. I mean, they all do the same thing. They all call the same code. It's just how you do it that changes. So blueprint callable is just that. You have your code in C++, and you are calling it in blueprints. Blueprint implementable is a declaration, or a definition. I'm sorry, a declaration. It's a declaration that's put in your header file, but the actual code is written in blueprints. And then blueprint native has a default implementation that is in C++, but can be overridden in blueprints. So that's what we're going to dive into now, after we create all of these. So we have our callable, and now we're going to create another C++ class, and we're going to call this myTeleporter Implementable. And then we're going to have one more called native. And I'm hoping by the end of this, once you see how they all work, that this will make a little more sense, and that we're going to discuss, how to decide which one's right for what you're trying to do. And there's one thing that I really hope we can get to, that I think is going to be, well, crap, I won't be able to do it in this one. Maybe. Let's see, hang on. While this is loading, I'm going to try and... Okay, so that's done. We need one more. C++ derived. Teleporter native. Create class. Cool. And while that's doing that, hopefully my computer doesn't have an aneurysm, because this is a brand new project and I forgot I don't have Shinby in here. And I wanted to use Shinby to do something fun, kind of bring it all together at the end. So let's add her to our project. Teleporter stream. Add to project. Okay, almost done. And really the teleporter callable one is pretty simple. It's basically what I was just saying that we could have done from here, but I want to kind of keep them separate. So let's take our teleporter callable. Let's create a blueprint class from that. We'll call this BP teleporter callable. Put it in our blueprints. Cube. And really, I probably should have set a default scale and in this. I did not. I purposely did not set a default mesh, even though you could, because I wanted to demonstrate that you can change the mesh even if it was visible only. And so now we're going to go down to our trigger, begin overlap, and we're going to. So the first thing we're going to do is I'm going to put a delay in here. No, I'm not. Okay. So we're going to cast to third-person character. And then all we're going to do from here is if that cast succeeds, then we're going to do, what did I call it? What's it called? I already forgot. It is called Activate Teleporter. Okay. Activate Teleporter. And then we're going to pass our third-person character into it. Save that. And let's put our teleporter out here. And let's do blue for this guy. 0, 0, 1. And then we'll just do blue. We'll keep them all the same so that we can see, so that we know which one is which. So here's my exit point. We're going to move our exit point over here, bridge this gap that I have, and then we also need to pull our entry trigger up so that we can hit it. Okay, and so now again, all we're doing is we have our overlap event, we're casting to our character, and then we are calling this activate teleporter. And you'll notice that we have activate teleporter available, but if we go over here and we look at our teleporter callable, there's nothing in our header file. There's definitely nothing in our CPP file, but it's because we are inheriting it from our base class. So play. We have our blue, and if I walk over this, we have our teleport. Boom. So, step one is a success. We have a function that we can call from blueprints that's written in C++. Awesome. Now let's talk about, that was the easy one. Let's talk about blueprint implementable. So let's come back to code. We have our blueprint implementable. And so now we're going to do a protected U function blueprint implementable event. Now, implementable and native are kind of weird on how they work. And I'll explain why here in a second. Let's just start here. We're going to do a void, and let's just call this the teleport event, and we're just going to put an actor in here, and we're going to call this, we'll just call this target actor as well. And that should be all we need. So again, we don't have any code actually in our CPP file. We have this teleport event. And let's wait for this to compile, or build rather, not compile, build. All right, so that's done building. And if we come back over here to this, we're going to create a blueprint of this class. And same thing, call it BP Teleporter Implementable, put in our blueprints. Cube. What color do we want this one? I'm gonna let you guys pick the color of this one. Think about it while I explain this next part. Now, how do we do green? Green it is. If we don't have any code in here, well, how do we get the code in? How do we get it over here? If you come over here to the functions, there's an override button. And you're going to see, here is our teleport event. And so what we can do from here, and this is the reason we wanted this exit point callable, is we can do teleport from here and plug our target actor up here. We can drag our exit point in, and because it's blueprint read only, it automatically knows that we just need a getter for it. And we can go, what do we want to do? What do we want to do? World location. Get world location. And this is the exact same thing that our code already does, right? So actually what we can do, let's get crazy. Well, no, we'll do that in a second. So we have our teleport event, and this is the same thing as our activate teleporter, right? So we're just pretending for a second that that's not there. So let's come over here to our map. We're gonna put this out here. Wait, yeah. Take our exit point. Whoa. Put it over there. Oops, that's not what I want to do, but this one's going to be green. And move our trigger up. And I know a lot of this is a little bit repetitive. I did that on purpose, just to keep some things simple. But if you notice, however, I'm not teleporting. I'm not teleporting because I don't have any logic in place to actually call our teleport, right? So that's a problem. And the other problem is I could just say, okay, well, we can just do our overlap event, right? And then we'll cast to third person character. And let's just call this event. Well, we don't have that event. We have our activate teleporter. So if we plug this up, if we plug that up, that works, right? But we know that works because we just did that. We just did that with our callable one. But that's not what we want. We want this event that we created up here, right? Well, so this is where you start combining your specifiers, because all this specifier says is I am implementing this in blueprints, because I can implement something in blueprints and then I could have code later on, more code that actually calls the teleport event function. So that's how you can implement something in blueprints and then call it from code later. All I need is the header. All I need is the header file. I don't need anything in C++. I can create it in blueprints and then call it in C++ as long as I have this event. Now, we're not going to do that because I haven't really thought about that, or how I would want to do that, especially with something so simple as this. We don't really need to do that. But what we can do is make this blueprint callable. And we can sit here and wait for this to load. I know I kind of threw a bunch at you right there, but did that make sense? While we're sitting here waiting for the build. Okay. Well, okay, let's do it this way then. Let's actually demonstrate this. We have our teleport event, right? And so let's come back over here, and we have our teleport event. Well, first, now that we have a blueprint callable, let me show you. We have our teleport event, and so we can now that it's blueprint callable, we have our teleport event here. And now we've kind of partitioned this out. But we've taken out our blueprint, our other blueprint callable event, and it does the same thing. But now let's demonstrate how we can use this to actually all right. So we're going to delete we're gonna delete this guy for a second because I know last time we did this, things got hairy when we started changing like events and stuff. So we're gonna separate this out for a second. We're gonna delete this and we're gonna do it again after Unreal catches up. So what I'm going to do is I'm going to demonstrate how we can implement something in Blueprints and then call that from C++. So it's not a matter of better. I am going to show you why it's different. But basically, what this method allows you to do is it allows you to push stuff to your designers that, you might have level designers that want to do something, or, your game designers want to implement a feature, but they're not programmers. And so this allows you to create the implementation on the C++ side, and you can call that implementation, but leave it to your designers to kind of tweak with it in Blueprints to get it the way they want to do it and not have to worry about code so much, is really what this method is for. So let's come over here to our implementable, and what we'll do is where did I put it? Hang on a second. I lost my notes. Here we go. Okay. So I'm going to copy this overlap function because I'm cheater. So here's the overlap function that we all know and love. And we also have our teleport event, right? And so now we're going to go to Blueprint Implementable, and we need a new constructor. Now, thankfully, this generated body actually calls the parent constructor for us, so we don't need to what we do first, we do need this. We need to declare our constructor, but we don't have to call the parent constructor. And what I mean by that is that we can now go with a teleporter implementable, a teleporter implementable, and what we're going to do is, what did we call, I keep forgetting what we called this. Entry trigger. We still have access to our entry trigger, and then we're going to go on component begin overlap, add dynamic, on overlap begin. So we are binding our overlap event to this, and now we're gonna create the definition. And so what we're going to do in this definition is the first thing we're going to do is first we're going to say if other actor and other actor is not this, and other component, excuse me, then we will call this teleport event. I don't know if I need the this, but I'm doing it anyway. Oh wait. I need to cast to make sure that I'm overlapping with a character. And then if target first we will call our teleport event on the other actor. And then we will call activate teleporter on the other actor. So let's come over here and look at it in whole. And I need to include the character. Let this build. I don't know why my computer's being so slow today. Does not take one. Oh, it helps if I call the right thing. Activate teleporter. Okay. Hang on one second. Okay. Shinvi's installing now. All right. So now we're going to come back to here, and let's remake our blueprint class. Create a blueprint class. And call this BP teleporter implementable. Put in our blueprints. And so, and all we're going to do here is, all we're doing, just for demonstration purposes, is we're going to put a print string to prove, hey, we're calling this first. And so it's basically going to demonstrate we've declared something in code, but implemented it in blueprints. And let's do print string. And actually, let's we're going to come out here and we're going to do an append node. And this is going to say teleporting get display name. Stop it. Teleporting this thing. So this is our teleport event, which is right here. It has no definition. It just has a declaration. Boom. So we are printing this string basically that's implemented in blueprints, and then we're actually going to teleport it, which is being done in code. So put this out here again. Put this over here. Raise our trigger up. And make it green. Let's save that. So we have our green teleporter. Oof. Let's put a delay in here. I ran into this earlier, that like if you don't throw a delay in here, that it's gonna fire the overlap event a lot. Let's try this one more time. So it should only print once. Boom. Teleporting third person character. Which was done in blueprints, implemented in blueprints, called in code. Does that make more sense now? Awesome. Awesome, awesome. There is one other weird thing about implementable events, but it's also the case with native events. So we're going to kind of kill two birds with one stone with that. So let's move on to native events then. Blueprint native events. So the difference between an implementable event and a native event is that native events have a C++ implementation that can be overridden in blueprints. Now, it's a little weird the way they do it, this is going to be true for implementable events as well. If a native event or an implementable event has an output, it will be reflected in blueprints as a function. If it does not have an output, it will be reflected as an event, and I'll show you what I mean. So we're gonna do two, and it's important to understand which one you want, and I'll explain why. We're gonna do two different events. The first one is not going to have an output or a return type. UFUNCTION blueprint native event. This one's not going to have a return type, and we're going to call this teleport native event. A actor target. And then the second one is going to return an actor. Teleport native, we'll call this function actor target. So in addition to, so like I said, these have a default implementation in blueprints. And so we need to, if it'll let me, not gonna let me. So we need to come over here to our code and implement these. A teleporter native, teleporter event, and then let's just cast character cast a character target. Actually, no, we don't need to do that. We're just going to assume that we've already verified that it's what we need, right? And so we're just going to go this activate teleporter target. And this is just for demonstration purposes. Obviously, like in general, you wouldn't need this if you already have this. I'm just showing you the different ways to do it. And so now let's do our other one. Func actor target. This activate teleporter target. Now there's one more thing we need to do. This is kind of a weird way that Unreal translates its code, but if you're doing a blueprint native event, you have to suffix your functions in your CPP file with underscore implementation. Visual Studio is going to be real mad about that, but that's just how it goes. And so now we're going to wait for this to compile. And so we have, oh, no, that's not going to work. Because what we need to do is we need a return type here. It's going to be mad at us. So this one has no return type, and so it will be an event in our event graph, and this one will be a function. And I'm just now realizing that, well, no, it's fine. I'll show you I'll show you in a second once it builds, because we're going to access these the same way that we accessed the implementable events. That they're going to be overrides in the blueprint editor. So we have our blueprint class. BP teleporter native. That's not where I want to go. .25, and this one will be red when it goes out there. Now, so we have here, so if we come over here to our functions, we have our override events. We have our native event. That's an event because it doesn't have any output or return type, and our native function, which is a function. And so let's do something crazy here. Instead of teleporting, what if we launch our character? So let's come out here and let's do a launch. Well, first we need to cast to third person character. And then as a third person character, we're going to launch. And so we're gonna launch on the z-axis. Let's do 500. Compile. So, and now let's come over here and let's do the same thing with our native event. And I'm going to show you how these are different and why, what you need to have. You know, this is something that I kind of figured out on my own while researching this. So we're going to do the same thing here. We're going to launch our character. 500. Compile and save. Okay, great. But we're going to run into the same problem. We're going to run into the same problem that we had with the implementable event. Because even though I have it here in my graph, oh, I didn't change the color. I still don't have a way to call it, right? So let's, well, first of all, color is important, which is funny for me to say because I'm colorblind. But all right, so we have the same issue, right? So let's come over here to our native event, and we're gonna make these blueprint callable with an L. Blueprint callable. And also, what I want to do is I want to add another property here. We're gonna do another protected section, because I like to separate my properties from my functions, even if they're all protected. I like to keep them separate. And so we're going to do a U function. I'm sorry, not U function, U property. And this one is going to be edit anywhere. blueprint read, no, edit anywhere. I don't think we need the blueprint read write. And this is going to be a Boolean, and this is going to be use event. And we're going to set it to false for now. And I'm going to explain why in a second. Blueprint use event. And let's build that. And now we hurry up and wait. And so once this is done building, we're actually going to make another copy of this so that we have one that uses our native our function, and then we have one that uses our event. And we'll see how they behave. Okay. So if we come back here now, oh, had to hot reload. We can now see in the same area that we have. Where are you at? There it is. So we have our use event, and we can select it here. We can also come in here, and if we go to our class settings, class defaults, sorry. So this is like really powerful for like when you're setting up properties. Anything that you want to expose to your designers, then you can just set it as, you know, as edit anywhere or edit instance only, and so you can put all of the code in the background, and then all your designers need to do is know how to use the properties you give them to do different things. So it's really cool. So let's pull another one of these guys out, and then this one is going to be true. And let's change the color of this one. Change the color. And let's just do white. Okay, and so what we'll do is we'll come in here and we'll take our trigger, do a component overlap, and then we'll say, well, first we will branch. Actually, no, the very first thing we're going to do is we're going to cast to third person character. And if that cast succeeds, we're going to. Oh, you know what? I think I need to add another property to our Boolean, but we'll find that out in a second. Branch, and I bet you, if I come in here and I look for use event, there's nothing here. There's nothing here. Because we didn't say that we could access this from blueprints. We can access it from the editor, but we can't access it from blueprints. So let's do blueprint read write. We're almost done. We're in the home stretch. Promise. Build. Okay. And so now we'll be able to get our Boolean once this hot reload's done. Okay. Use event. We can get it, or we can set it. Not really worried about setting it, but just to show you how that works. So, I'll show you. Use event, set use event. We could set it as well. So this is a way, again, that we can expose variables to our designers, but they don't have to worry about creating them themselves. That makes sense. And so now what we can do is, if use event is true, then we're going to do teleport native event. And if it's false, we're going to do teleport native function. Now, if you're looking at blueprints, it looks like these things do the same thing, right? And I'm going to show you why that's not the case. So we have our first one that's red, and that one is set to false for our event. And then we have this one, and this one is set to true. So if we play this and we come to this first one, now in theory, once we overlap this, we should launch our character. Oops. I don't think this is high enough. Let's do something crazy. Let's just do like 10,000. Because I thought I saw something. Whoa. What is that? Okay. I thought I saw it do something, but I don't think it was enough. Okay. So let's try again. That's not what I expected. That is not what I expected at all. Set target as character for those after. Yep. You're right. Thank you. Good call. I'm getting excited. I'm making easy mistakes. All right. Try again. Boom. All right. So that's a little ridiculous. But it did what we wanted, right? So let's drop this back down to 500. One more time. Okay. So didn't make it across, but we launched. Now, here's the weird part. Let's make this 1,000. 10,000 was too much. 500 wasn't enough. If we use our event, and I try and do the same thing, well, that's silly. When I tried to do this the other night, I had a print string in my event. So I was trying to prove a point to answer that question, and I just proved myself wrong. Because the other night when I was testing this, I had a print string in my code for, I had a print string in my code, right? And even if I overrode it, the print string was still firing. And so I was like, well, that's weird. And so I came to the conclusion that events don't really override, they just add to, but it doesn't look like that's the case. And so we can actually, if we delete this function, so let's delete our native function. And now, if we come over to the red one, it teleports us. So this is an interesting way that you can use maybe the same visual assets, or maybe you have other code that works with this also, but you want a little bit of different behavior. You want this one to launch, but then you want another one to actually teleport. You can have the same framework, but the implementation is different. And I was apparently incorrect. You can overwrite either events or functions. Alternatively, what you can do is, let's say, same thing, right? So it's interesting that this is here now. It wasn't here a second ago. Let's say you want to add to functionality. So we want to teleport and then launch. We can use this parent node. We got to cast in here still because we're using an actor reference, not a character reference. And launch is a character function. But if you have this parent node, well, then now I can come over here, it'll teleport, and then I will launch. Pretty cool, huh? So that's how native events work, and that's really the difference between implement and native, is that one, all of the implementation that's OP, I know, right? So with one, all of the implementation is in blueprints, and that code can be called from C++. The other one, you have a default C++ implementation that can be overridden or even added to in blueprints. So there is one last thing that I want to do. We got a few minutes left. I want to try something, and I think I want to do it with I think I want to do it with the callable one. I've been thinking about this all week, so I'm going to do it. Yeah, I'm going to do it with the callable one because this is kind of a, I guess you could say it's a demonstration on how to, provide code for your designers without them needing to understand how it works, right? And so what I'm going to do is we're going to open up this callable one, and instead of just teleporting, we're going to get rid of that. And we're going to open up our Shinbi character that I threw in here. And I just want to filter for a blueprint class. Come on. Okay. And so we need to add a couple of variables, and I'm just going to do this. I'm doing this in blueprints, A, because it's faster, and B, this is a native blueprint class. There's no code behind this, so it has to be done in blueprints. And so we're going to do teleporter. And this is going to be of the type teleporter callable, object reference, and we're going to do is teleporting. No, we're not. We don't need that. We just need a teleporter. We just need a teleporter reference. And so we're gonna come up here. We're just gonna use the capsule component. On component, begin overlap, and first what we need to do is we're going to come over, we need to reopen our callable. No, we need to open our base. We need to open our base header file, and we need to change this trigger to, or not change it, but we want to add to this blueprint read only. Because we want to be able to access that component. I should have thought about that earlier. Mainly what we're doing is we're going to isolate that component. That way the capsule component doesn't fire this as soon as we overlap with the mesh. We want this to happen only when we overlap with the trigger volume. But in order to do that, we need to be able to access the teleporter's trigger volume. Doop, 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 doop. So we're going to cast to our teleporter callable. And really we can do this with any of them, but we're going to do it with this one just because it has the least amount of implementation, like code implementation, that is. And so then we're going to get our entry trigger. We're going to branch, and we want to say if this is equal to our other component, then we're going to do the thing. And we're going to do the same thing with end overlap in a second. Actually, we'll just set that up now. Other actor, other component. And so what we're going to do is we're first going to set our teleporter to that. Oh, I messed up. We want our BP teleporter callable, not the code base, not the C++ base class. Get entry trigger. Yeah, you're right. I can. I always forget about it. Okay. So there's that, and there's that. The only difference here is we are getting rid of our teleporter. So basically, on overlap, we are assigning the teleporter. On end overlap, the teleporter is going to be null. Okay. And then also what we're going to do, after all of this, we're going to play a montage. Nope, that's not the one we want. Montage. That's the one we want. And the montage we're going to play is the level start montage. And now we're going to go to, oops, that's not what I wanted to do. We're going to take our animation blueprint and we're also going to get our montage and a montage. Okay, so this is our level start montage, and I want to come right here. That's where I want to be. Same place as, oh, okay. So let's go a little bit after that. No. All right, we're gonna move this guy. Because I want to add a new notify, and we're going to call this notify teleport. And so now, in our level blueprint, notify teleport, and we're gonna get Shinbi, cast to Shinbi. And then we're going to get our teleporter. And then our teleporter is going to activate teleporter. I really hope this works. The other thing we're also going to do before this happens is we're going to get our character movement component, and we're going to stop movement immediately. Okay. Oops. And I need Shinbi. I also almost screwed up again. Forgot to plug her in there. And if I recall, oh, it's in our base. Yeah. So all we're checking for is an actor. So we should be good. We should be good. So we're going to get rid of this guy. We're going to possess. There we go. Disable AI. And if everything worked properly, we should be able to come over here. Okay, so the location's a little bit off, but it worked. And so now you have a meaningful teleporter rather than just bloop, you're there. Okay, and bloop, boom, teleport. So that's a way you can, like I said, you can have your designers Yeah, exactly. It's a fancy delay. You can put all the code, put all the logic of, okay, get the location, get the rotation, put them there. That's all happening in the background, and all your designer needs to worry about is, okay, well, I'm gonna have this teleporter, and I'm just gonna call activate teleporter, and boom, done. So just different, and it all depends on what your workflow is, who's on your team, what their skill sets are. Another thing is, like, when you're talking about, okay, do you want to use an event or do you want to use a function? Well, some things that you need to know is functions don't have any concept of time, so you can't put a delay in a function. You can't use a timeline in a function. That all has to be done in an event. Events also happen in when you said I want to make a teleporter, and I was like, well, we can make a teleporter. That part's easy, but let's think about how can we improve on that and make it actually look like something that's cool to have in a game. So events also happen in a different thread. So, like, if you're using a function, that function is part of a larger thing that's happening. Whereas if the thing you're focusing on is the teleport, that probably needs to be an event that's happening. So really, I used the blueprint callable just because that was the easiest one. But really, you probably might want to use like a native event or an implementable event and have this event part that's doing all the work for you rather than a callable function like what I did. I took it to the moon because I really wanted to take some time to look at the different, the U function properties and the UProperty specifiers as well, and I thought this was a really easy way to kind of kill two birds with one stone. So you now have 4 different ways. I guess 5 different ways. You can have it built in blueprints. You can have it built in code. You can have it called in blueprints and written in code, and then you can have it done the other way, or you can have a little bit of both. So now you have options on how you want to implement things. You can do some of the hard stuff in C++, or even blueprints and put it in C++. Just different tools in the tool belt. So before I sign off for the night, you have anybody have any other questions or over anything we did? Any requests on what to do next? I got another project that I'm trying to get off the ground, but I need a little bit more work on some things before I'm ready to tackle it. I need to do some more research. So if anybody has anything else that they want me to cover, I am open to suggestions. But if not, I know this one was long. I wanted to try and keep these to an hour, but I think they're probably going to wind up being 2-hour streams depending on what we're doing. You want to do AI? We can do AI. I'm not as well versed in AI, but we can tackle it. If you wanna shoot me some requirements of what you're trying to do, we can kind of play around with it and see what we can come up with. AI is a tricky thing, and I don't know how I can initialize a blackboard and a behavior tree in C++, but most of the ways I know how to do AI is going to be in behavior trees and blackboards, or even using like AI nodes. But we can definitely cover that next week if you want. I know that's a tricky topic, so I'd be glad to help out with that. All right. Yeah, so went a little bit over what I planned, but I hope you guys got something out of this, and we'll do it same time next week. Have a good night, guys.